Hey guys, we are recording this session, and what we were doing the last time was let's see what let me. So I have two programs going on, and I just get confused. Even with just one program running, I get confused about what are we dealing with, and that is something that I need to refresh. So let me take a minute to remember what we were talking about because I am at a loss almost all the time. So Firefox, and what is this? Oh yeah, you should see this news. If you haven't seen this, you should see this news. It's a hack that China used a tiny chip to infiltrate into US companies. That is something to think about and just read. That is something I think you should read if you haven't been up to speed on what the news is. So that's the latest news in technology front.
Huh? I hadn't heard that.
Yeah. So what the news essentially is that there is this company called Supermicro, which is used as a company to manufacture motherboards for servers. And so they make motherboards, and in the board there's like a tiny little chip implanted by Chinese operators. I don't know who. That's the claim. It has, people are refuting it, but so so here is the board, and there is a tiny little dot you will see somewhere. Maybe the illustrations are not right. So yeah, there it is. So that's how small the thing is going to be on a smaller than a nail, and it was implanted on motherboards through Supermicro, which was Supermicro is a primary motherboard provider for servers. Many companies use it, and so the situation is that now that we have this hardware hack, it's news. So I cannot say that they have it or not, but that's the news.
Mhm.
So somebody will validate and verify, and essentially find out what is going on. Is it really true? If that's the case, we have a very systematic hardware hack, which is
Yeah.
you cannot really stop that with software updates and patches.
Mm-hmm.
That's the challenge. So you should read that news on your own.
Yeah.
Having said that, uh, we will now go to that website. What was that? Yeah, that one. And what were we doing? We were looking at VPC, if I remember. And I'll also check one more thing, which is how many days have we gone through in the program? So that will give me an idea about what we should have covered and what we haven't and what we be doing. That's what I want to capture. So if you look at our program dates, where are the dates? If you look at our program dates, they should be so calendar should tell us. Calendar, and the dates are 9/11. Is today 9? No, that's not the wrong thing. This. So today is 5, 8, and 10. So we have 3 more sessions to deal with cloud technologies before we jump on to cloud DevOps. And so with that, I'm just thinking as to what we should primarily focus on, making sure that we understand. I will now quickly recap before I go deeper into this discussion on VPC again. So what I am currently trying to do is wrap up my mind around what I want to focus today on. So what I will actually do is erase whatever I did the other day and begin this time in a little more comprehensive way about thinking for high availability in a virtual private cloud from a corporate deployment perspective. So last time we did this, we created a VPC called Cloud Genius. It had 2 subnets. So let me filter. I will filter it, and you see that these are 2 subnets here. And that is, there are 2 route tables. One of them is ignored. There is one gateway, and we didn't even look at the other options. But just saying, that's what we had. It's a very, very a very simplistic design, even for a VPC. It is a good design, but it doesn't deal with failovers, doesn't deal with high availability scenarios, and doesn't deal with large scale corporate application deployment. So that is something that I would like to now talk about to make sure that you get that other perspective also, which is important. So having said that, what I'm going to do now is maybe get rid of this super micro thing here. And there. So if you remember and recall, in our original design idea, what we had in our VPC here was something like this. We went to an Amazon location. That location was Virginia, if you remember. And in there we said, give me a portion of your cloud that I will call it my VPC. And then we gave it a subnet of this size that will give us 64,000 machines, or rather IP addresses within our VPC. And there we created two subsets. We call them subnets. We call them public and private. And these guys had a subnet range of like that. That's the allocation we did. We created a machine here called NAT. We created another machine here called Jumpbox. We created a machine here. We had some security rules. We had a gateway here that allows people from the outside to get into the units here and here, for example, but no route here. And for this machine to go outside, the only route was to go through the NAT. That's how we have structured this simple, but it's a complete design, but it's a simple design. And so that's what we did. Now, having understood that part, I will erase parts of our design and now give you the idea about how to make it highly available. The availability scenario, the first thing you probably notice is when the NAT goes out, you have a black hole so that these machines cannot really talk to the world outside. That was the black hole discussion I think we closed with. So there was no route to go out any further, any forward once the NAT goes out. And that's a bad situation when you cannot have your machines deal with an outage. So what do? You create a situation which is slightly more reliable. So we will think about that now. And that's what we want to do, is erase these guys and build it again in a different fashion. And so erasing is as simple as going to here and saying, my subnets need to be deleted, like that. And another one, delete. And that's how we got rid of our two subnets. Now we'll also go to the route tables, and these are public and private, we can delete them. And so they're also dead. That's a good cleanup. After having cleaned up, maybe, I don't think we can delete this one. Maybe we can, I don't know, we'll find out. Yeah, cannot delete. It's given to us by default. So we just ignore it. And then we have gateway. So gateway is like a connection we need for our cloud. So this is the overall cloud, by the way. So inside we have our own portion of the cloud. But for purpose of illustration, I'm saying that, this is our VPC, this one. So the overall cloud is actually bigger. So this is just the portion for us. Now inside here, what I want to do is put a gateway. And the gateway, I think I labeled as Xfinity Comcastic, which is the name that I chose. It is not from Comcast. It is provided to us by Amazon. And that's the gateway now we have. And like that, this gateway, it has to be associated with your VPC ID. So that association is clear. You can actually see and disassociate and detach from VPC if you don't want it anymore. You could do that. But we don't want that. We want it to be connected. Just like this internet gateway, there are other types of gateways available. Like, for example, this one. We are not using it, but here the idea is egress only gateway. So the idea behind this type of gateway is suited when you want outbound only. So things that go out, meaning public, here people like me and you, us, we cannot go inside in an egress only gateway. It cannot go. It's no ingress. Ingress not allowed. That's the idea behind an egress only gateway. It functions pretty similar to this type of gateway, which allows both ways access. So there is an ingress access and there is egress, both E and in. Both are allowed in a regular gateway, just like we have this one. But this gateway does not allow that. And so we are not using it. I just want you to be aware of the fact that there is such a thing called egress only gateway, which we are not currently using. There is a business use for it, in which when you want your machines to update and you don't want anybody from outside to get in, that's what you would use. In our example, we are not using it. There are some option sets here we can classify and call out. And this is basically providing what are known as domain name extensions. So what you will notice here is that when you create a machine, it will assign some internal domain like .ec2.internal, like that. Some internal domain DNS assignments will be provided by selecting this option. And this setting actually needs to be selected and called out in the VPC section right here. And here somewhere there is a option set assignment. So they have given us an option set assignment, or we can not use it. This is more of an internal naming, machine naming, or assigning names to DHCP based solution for machines inside. If you don't know what a DHCP does, it gives you, so imagine that, maybe another sheet of paper. So this is here. So my home, your home, any of us homes. So there's a router here, and what that router does is gives you IP address to a machine inside. For example, this is the machine called iMac, and it has an IP address of 10.0.1.128. So that assignment was done by the DHCP running here. Dynamic Host Control Protocol server is a part of the router, and it assigns you IP addresses like that. It also might generate long names that may look like, in Amazon's example, that may look like some machine name .ec2 internal, like that. So they may get machine names assigned. For example, this machine may be called imac.ec2.internal, like that. It might get a name like that. From an example perspective, if you try to see what is the name of my machine right now, you can just go there and say hostname imac.local. That's the name that has been assigned to my machine from the router. If you check ifconfig, you will of course see the 10.0.1.128 IP address. I have so many different Ethernet adapters. I just focus on the right one, which is this one. So that's the IP address assigned by the router. It has also generated a local .local name like you saw here. And so this is the function of the DHCP option set. It assigns names. So that's this thing, DHCP option sets. In addition to this, there are other things that we'll go down the chain and discuss these things before we start using some of these things. So if you now look at the next item here on the list, we have this thing called Elastic IP. And Elastic seems to be a favorite word that Amazon seems to love. And there's nothing wrong with that word, but actually in this particular example, the word elastic kind of means that it can change. But the idea here with Elastic IP is that it would not change. So it is actually static IP. So when you want to get a dedicated IP address allocated to your whatever inside your area. So whatever you have inside here, and you want to put some dedicated IP address on the public front, like here, public IP, you want to access something inside here with a dedicated public IP address that should not change, you typically get a static IP assigned to you. And that is what this Elastic IP is. It is a static IP. Just Amazon likes to use the word elastic for some reason, but it is static IP. So you can allocate an address and you can just click allocate and they will give you an address. And you can then use that address to assign it to wherever you want, to this machine, to that service, to this node, whatever you like. So basically you get to choose, pick and choose where do you want to associate this IP address with what inside. That's the concept. And the name Elastic to me is kind of wrong because it is frozen. It's not elastic. It's not changeable. But then come to think about it from another perspective, it is actually elastic in that you can assign this IP address to this machine and maybe change the elastic and maybe go here and maybe change it to go here. The number remains the same. That's one approach to thinking about. Other clouds just call it static IP, for example, here. Where is that one? Yeah, that cloud will call it just static IP. And in fact, I have one static IP allocated to my live environment, and that you will see here in the Kubernetes workloads and services. And that is the number that you see here is assigned to one of the controllers here. That is a static address. So if you take note of this 198.209 and we click on it, that's what you receive, default backend 404. So nothing is actually shown to anybody who visits the site, but that's the static IP that I have. And that means that all of the services that I run in my company are pointing to that same address. You can see that it's the same address right there. And that was the one that you had here, same address. It is the static IP. So that's, I got one, I have it, I'm using it. It is called static IP, as you can see from here. Hello, where is your static IP applications? Network, maybe network services, load balancing. Where is the static IP reference? It's hard to find sometimes, but it's there somewhere. Network, VPC, external IP. Oh, they call it external IP address. So that's the name. So here is the IP address that I seem to have. Why do I have another one? Why do I have two addresses? No, it's ephemeral. It is not static, which is okay. Ephemeral addresses are not chargeable. Static IP is typically you have to pay for it. So I am paying for this address, which is the same that I was talking about. And the same idea applies to this concept. If you allocate, you are paying for something like $3 or $2, so some monthly charge for an allocation of static IP. You can do the same thing by command line if you like, but not right now. So that's the concept behind a static IP, also known as elastic IP in Amazon or other names in other clouds. Elastic IP, you got that idea. Let's go endpoints. I think these are endpoints that are get exposed, that you will create a service. You can then use that as a endpoint where you can associate this IP address to that endpoint, or maybe this endpoint. So you will see as an example, as will come up, endpoints will come up. And as you create new services or new resources, they will show up. And same here, endpoint services. If you create a service endpoint, that will pop up right there. In addition to this gateway, like we have, and this egress only gateway, like we just discussed, there is one more type of gateway available from Amazon, and that is called the NAT gateway. And this NAT gateway is a service, I think, unique to Amazon. They give it to you for a charge. It is not free. This gateway is free, by the way. It comes along with Amazon services. So there's no extra charge for that. But this one, there is a charge. So when you create a NAT gateway, what you're really doing is actually creating a NAT. You are creating, just like we created by hand, because I like to do nothing by any of these tools. So I create everything by hand. But what we did, if you recall, is that we created a NAT machine and then use that NAT machine to give access to these machines inside in a private area. And so these machines could then connect through the NAT and go outside if they wanted to. So that NAT was created by us. So we created our own NAT gateway for these machines to go out. But Amazon will make it simple and easy. And you can just create a NAT gateway by clicking and selecting a subdomain. Now we have some subnets, but they don't belong to the right VPC. So we have to go carefully dealing with this. You cannot just randomly select, and they all belong to the ignore VPC. We don't want anything in the ignore VPC. We want it to be in our VPC, and in our VPC, Cloud Genius, we don't have any subnets yet because I deleted them. So we'll get back to this. But what I would like you to do is to not use this gateway like they're suggesting, but instead learn to do these things by hand by yourself so that you really know what's going on. When you use their gateway solution, they will of course do the same thing. In fact, they will go do 2 NATs at least. So there's a NAT here and a NAT here, and they will be in separate subnets. There will be public subnet, and there will be another public subnet. And the idea is what I'm now extending is to look at the concept of high availability, which is this idea that you just had 2 public subnets, and there is a gateway that connects to both. And this, you can go outside, people can come in like that. So similarly, we have to have a naming difference. So let's call it A, and let's call it B. And similarly, we will have a private area here and a private area here. Let's call it private A and private B, like that. So this is basically giving you high availability of things in your setup. So if something goes down or this whole thing goes down, you still have a way for these machines to go out from here. But typically, things will be working fine. And so you will not have a situation where things are not working. And so in that scenario, these machines will go from here and like that. That's how the traffic will be routed in the normal circumstances. If something goes bad in here, for example, then these guys will start communicating through that NAT route. And that is how high availability concept is what I'm just introducing to you. Now, in order to enable this A and B and A scenario, we have to understand what does these cloud companies give us. So if you look at our cloud, not here, go back. If you look, go back, yeah. If you look at almost every cloud will give you that, the idea of high availability. And you will see that in, say, for example, EC2 section, and you try to go and create a new computer. And let's say select this Linux, and then you select T2 Micro. That's the cheapest you can get. Then you say that, you know what, I need to get this. I think we should first create a subnet, but I'm just giving you an idea. So if you select a VPC called ignore, for example, then you get to choose which subnet you want this to be created. And there are like 6 of these guys, E, A, F, C, B, D. So 6 of these, and they are in different availability zones. The idea of an availability zone essentially is that they are fault tolerant zones of locations that are kind of sort of separate from each other. So in case of Virginia, did I discuss the idea of availability zones early on? I think I may have, if I remember, but I don't exactly remember. So I'll quickly give you a quick summary. The idea of an availability zone would be that all these A, B, C, D, E, and F that you're looking at are actually different buildings in somewhere in Virginia. And so you want to have one subnet here, and maybe one subnet here, and one subnet here. Or maybe not have 3 and only have 2, but it's your choice as to how many you want, how many levels of redundancy do you want. And so maybe you want to have only 2 and not this. And that's completely up to you. So from our initial design perspective, what I want to actually do is to create 2 subnets. Let's call them A and B. And so in here, I will have a public A and a public B. And here I will have a private A and a private B. And so now that I am thinking of creating subnets, 4 of them, I need to be clear about what will I be numbering them, which means I don't have current subnets right now. in the Cloud Genius VPC, I have nothing. So I want to create a subnet. I want to create these guys and call them public, let's say A, like that. And that's the kind of name I want to choose. But this VPC should be the Cloud Genius VPC. And then I want to select my availability zone very, very carefully. Early on, I did not, but now I'm going to focus on A. And here I want to give it a CIDR block. Now I need to understand what CIDR block do I want to give them. Maybe this is a good idea. But whatever we want to give, we want to make sure that we understand and keep track of. So here, that's how I am thinking to assign various subnet CIDR locations or CIDR ranges of addresses to these 4 subnets. So right now, this is going to be in the A availability zone. So here, my plan is to just use the number 10 for A and number 11 for B, 20 for A, 21 for B. And you can have, the same idea, extend and expand to even more. For example, you could go the same way and say, I have a C public subnet. So I may have 10, 0, 12, 0/24. And same idea further expanded to go something like this, which is, I need to maybe draw it again. So I'll draw it again. So we have public A, public B, public C, and typically, it's limited to like 6, sometimes more, but it's very rare. 3 is the most common. You will see three different availability zones in most clouds. Some clouds do it better, like in case of Amazon's Virginia region, you have up to 6. You could have 6 availability zones laid out like that. And then we have private, A, B, C, F. But this doesn't limit itself to only a section that is public and another section that is private. But you can actually conceptually divide your subnets into logical groups that cater to what do you want to put as applications or services in those subnets, and whether or not these things will be publicly accessible, meaning connect to a gateway directly, or not. If they are not connecting to a gateway directly, then maybe they are going through a NAT device sitting in here and a NAT device sitting in here, like that. And you will go through the NAT. I think you understand that concept already. But what I am now introducing is another idea, is that you can have another set of subnets that is dedicated to something else, which is not exactly what you have here, but something else that will run some other service for you. For example, you can store application servers here and have your database servers here. And the reason why you would like to separate them like this is to put a logical division and not mix them together. That's one idea. And of course, you will have a database subnet. Let's call it database subnet A, and database subnet B, and like that. Database subnet up to F, or sometimes even more. But within that subnet, you will have machines called database machine number 1, A, 2, A, like that, and any number of these. And these database servers will be serving your application servers, and they will respond to whatever you might have as a request. And there is no reason for any of these things or anything else you might have in your cloud or another subnet for them to connect to the database, because any access that we provide to anything even within our cloud has to go through absolutely only when there is a need. The access has to be need-based. If there is no need to open a port, if there is no need to open a protocol or a security group or anything like that, you will not open it. You keep it closed. The only thing that will require you to consider opening something from a security standpoint is only when there is a need. And that's how you should think from a security standpoint. So now we will actually go begin implementing this concept right there in our example. I'll now put this back here. And look at what we plan to do is maybe not the C part, just A and B for now. So there will be A, and B, and we will extend it to maybe include another subnet called database. And we will number it something like, so let's call it database A 10.0.30.0/24. And another database here called 10.0. And can you guess the number here? What should that be? 31. Again, these are not requirements, but these are my logical choices. The thing that I find logical, it doesn't have to be like these numbers. Like I'm just making stuff up. And I'm saying 1331 for the third subnet, and 2021 for the second subnets, and 1011 for the first set of subnets. But these are just my ideas. You don't have to follow these. You can put random numbers, it doesn't matter. As long as they do not overlap, it doesn't matter. You can put whatever you like. I go it this way because it, I think, helps me understand what I am doing. That's the only reason why. All I'm making sure is that there is some kind of logic in my mind about what the numbering schemes are going to be. And yes.
Is the 10.31.0 supposed to be DBB?
Yes, sorry.
Okay, just making sure I was following you. Gotcha. Thanks.
Yeah, I did not write it properly. So yes, good catch. So the idea behind these numberings is totally up to you, as long as you don't overlap. That's the only constraint. There is no overlap, I mean, totally no problem. Do whatever numbering you like. It's totally up to you. But when you design a bigger picture, you want to think through these things ahead of time before you start putting those numbers there, like this, for example. And I can, of course, put that numbering scheme and say, this is my public A. It goes in the East 1A segment. And then I say, okay, create. And I'll do the same thing again for another subnet. I'll call it public B. And then select the B segment and put the number 11 there. That was my plan right there. And so again, these are not set in stone. You can do whatever you like. Make sure that you're on the Cloud Genius VPC, that 1B is carefully selected. This is the critical thing to understand. When you're creating different subnets, you want to make sure that they're in different availability zones. You can, of course, put this in F. It doesn't really matter. But yeah, just put it in B for consistency in your mind. You can, of course, put it in E and call it B, or call it whatever you like. These names are irrelevant. But it's good to have some sense of what I call sanity in your own head as to what did you do. That's the only thing that I like to number like these, but nothing is set in stone. It's totally up to you. You can create a mess, havoc. As long as you really understand your havoc and mess, I'm fine with that. I have no problem. But this is, I do it this way just to help us understand what are we dealing with. There is totally no rule to go this way or that way. The only rule is no superimposition, and make sure you're secure. Make sure you understand what traffic flows, what doesn't flow, and what should flow, what should not flow. And rule of thumb, allow access only and absolutely only when there is a need. If there is a need, you open. Otherwise, everything is closed. That's how you should design everything. And these things, as you will understand, the idea of security groups, which is also known as firewalls, also known as firewall rules. You have to really think carefully on every line item that you put in your list of rules, which is what you will see me do. And I'll explain each and every one of them And most of the times you will see that when I put in a rule, it is kind of minimal, very, very narrow, and I'll slowly expand it when I see that there is a need for it to be expanded. You probably have seen this. You probably have seen me do this before, when I will do something very, very narrow, and then I will show you that it doesn't work. Then I'll come back and expand it a little bit, a tiny little bit. It's very easy to expand the whole thing and open, allow, and every access. But that's not what you should be doing. Only when needed, you open only the traffic protocol and only the port. Even go to the extent of allowing only for the duration of time that it needs to be opened. That's how you should configure these things. Then we'll talk about the time aspects later on, because in practice, you will not be creating these subnets or allowing security group rules to be created by a mouse and a web browser. That's not what we will be doing, by the way. We will be doing it through code. So you will write code, you will see the code to do these things from a programmatic perspective, meaning whatever I'm doing right now, you will do the same exact exercise in one line of code. And yes, you will see the whole thing coming up and running in one line. And yes, we'll get there. We'll build towards it. And you will see that you can create an entire entire VPC with subnets, with security groups, with machines in there, and NAT, and routing, and VPN, and all of these things that we talk about. One line of code. Of course, the code behind that one line will be a lot of it. There is already exercises written like that in somewhere here. You will be able to find it. You have access to it. So you should be able to just quickly see what I'm talking about by going to maybe this segment and just reading ahead, just to satisfy your curiosity as to what am I talking about. Is to, where did I go? No, not here. So close and search for NTIER. What am I typing? EIER. Yeah, that one. So blueprint for an N-tier architecture. And this is the exercise that we will be doing at some point. And there is a video walkthrough as to how to do it. And that walkthrough is this three-hour long video. So that's there. And you can, of course, go ahead and read it if you like. But this is the end result that you will have. And the code is already available in that repository. And it's right there. And you invoke it, and you will see the whole thing automated. And you will know how to write these things and update them and maintain them for yourself. And all of this thing is open source, all of it. So like this picture, for example, here, what are we doing? You can see that the yellow area here, this yellow item is a subnet. This yellow item is also a subnet. This first yellow here is a public subnet. The other one is a private subnet. There is a user, he or she has a machine here. They are using a load balancer. There is a gateway available. There is subnets and a bunch of other things. We are creating them by hand right now. But you will create these things through automation, pretty much like, where is that? That is the one line that creates it. Terraform apply. That one line will do it, the whole thing. And of course, you can tear down everything that we have from Terraform destroy. That one line will kill everything, like completely get rid of whatever you created. And this is how you will see what we are building towards, building to understand the concepts to do these automated exercises later on, not right now, but we'll get there. Right now, let's do it by hand. So public B, 10.0.11.0/24, which was this one. So not in the E segment, but in the B segment for my own sanity, and create. Then we have create subnet. Let's call it private A, and put that in the A segment. And the CIDR block will be 10.0.20.0/24. And create. And one more. This one is private B, and it's in the B segment. And the title block is 21. Create and close and create more. So database in here, and we'll put that in the A segment, and the cider block will be 30 and create. And then one more. It's kind of boring if you think about it to do it by hand, but I guess that's what we need to understand and then not do it again by hand. 31, database B, and create. So we have a bunch of different subnets created, 6 of them exactly in our Cloud Genius VPC, and they're here. ABC, 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 you can see them. Database subnets, there are 2 of them. Private, there are 2 of them. Public, there are 2 of them. If you go to route tables, we have none. So we create a route table, call it public, and put that in the Cloud Genius VPC, and yes, and then one more route table. I shouldn't have deleted the route tables, but I just did. It's okay. We create it. Takes a few seconds. This is a private route table in the Cloud Genius VPC, and create. Now that we have 2 route tables created, and we have the third one to ignore because I never use that, because somebody who gives it to me, I don't know what they have done. And more importantly, I actually know what they have done, but the idea is to understand. And that's the reason why I'm not touching the ignore one. I would rather create my own public subnet association and edit to select all the public dudes here, 1, 2. They are the public subnets, so associating them with the public route table and save. So now I have my association clear because I know that I know what I did. What I did was I took all the public ones here, public A, public B, associated that with the public subnet and left out these private guys, all of them. They can be more, but I don't want them to be public. I want only these guys to be public. So I'm associating them with the public subnet. And now on the routing side, on the public route table, the routing is limited to only the VPC. So I want to expand it and say add another route and let it go anywhere on the internet using our Xfinitely Comcasting gateway, and then save. So that routing for public subnets are now established. If you look at our private route table, it doesn't have a route to the internet because there is no NAT yet. We need our NAT here in order for us to go like this. And I need my NAT. I don't have a NAT. So I cannot do this right now. But I can associate subnets. I have 4 private ones. So private A, private B, database A, database B. Database doesn't go connect to the internet directly. Therefore, that's also by meaning private. Maybe I should just rename my subnets and don't call them private, but instead call them application. And this is my application B. So I'm renaming my subnets in a little bit more meaningful fashion as opposed to keeping them private. Just relabel them as application. Now go back to the route table. Think of the private route table, which is a private route table. And there I want to associate all these private subnets. They are the app A, app B, DBA, DBB, and then edit and say, hey, all of you guys, 1, 2, 3, 4. You associate yourself with the private subnet. So save. So I did that association, and now my association for the private subnets is clear. I mean, it will become clear as soon as the saving finishes. And when it does, you will see it. Hello, Amazon. What are you doing? Oh, there we go. So 4 subnets associated. Those are these guys, app A, app B, DBA, DBB. Those guys, and you can see the cider blocks, and you know that they are associated correctly with the private subnet. Now the route section is still, we don't have a route. So we'll address that. Once we have that, we'll come back here and fix it. We have a gateway that is a good enough solution. We are not using this. We are making sure that I think that is already selected. Elastic IPs, we are currently not interested in getting one, but rest of these things are useful in various scenarios as they will come up. You will notice that there is a security group that we have. We created a NAT security group. So let's call it NAT. We have a jump box security group. Let's call it jump box. And we have an application security group. Let's call it data application. And we have a default security group given to us by the VPC creation. We'll say ignore this one. We're not using it. And this app label apparently did not apply. So I will apply that label. So there are the 4 security groups that you now have. Let's make sure that the ignore ones and read it, what they have done. So you will see that the outbound rules are all traffic allowed to anywhere on the internet. So that's what you know from what they have given to us in the default group that they gave with the VPC. Inbound rules, we'll also take a look at what they are, but just a minute. So outbound is clear, goes everywhere you want to go. All traffic anywhere, any destination. Now look at the default security group called ignore and look at the inbound rules. And here you will find all traffic, all protocols, all ports. Huh? What is that? What is this? That's what I want to think and understand. So this thing actually pertains to, if you read the number carefully, EF2 at the end, it pertains to itself. EF2. If you look at the security group ID, it is the 4EF2 right there. It is itself as the source. So as long as the source is itself, all traffic is allowed. What does that mean? It means if you are within that security group, then you can talk to anything and everything, provided you are inside. So that's what you understand. It might read like all the traffic is allowed, but let me tell you that the way I would read this is, yes, all traffic is allowed, provided the source is itself, which means no traffic is allowed from outside. You cannot just get to it. So that's how the nomenclature or the inbound rules are sometimes written, that you can write it like that, in which we're basically saying that all traffic okay, provided you are a family, you are in the group. That's the idea here. You can come in provided you are a family member. So that's what family membership is trying to communicate with the number 4EF2, the same number repeated here. So that's the idea behind this structure of inbound rules that sometimes people get confused about. Hey, all the traffic is allowed, but nothing works. Why? Because you're not a member of the family. That's why. So that's what we understood with this ignore thing. But now let us ignore it. Let's go look at these other groups and make sure that they are very, very minimal. So from a outbound rules perspective, all these groups should be open to anywhere they want to go. Let them go. That's okay. These are people, or rather, these are machines. Why do I call them people? They're machines inside, right? They're inside our VPC. So there is, assuming that there is no bad code running on our boxes here and here and here and wherever they are, assuming that there is no bad code running on our own boxes, which is kind of a reasonable assumption to begin with, that you can say that, my boxes are good, so let them go to wherever they want. And so that's how you should begin thinking. But again, you can argue that, I don't need these guys to let them go outside wherever they want without me understanding exactly why they are doing it. And that's a fine assumption. And so in that case, you remove your outbound rules and narrow them down. But for right now, we are focusing our attention on inbound rules. So we'll focus primarily on inbound, but just checking on the outbound side that all these 3 custom security groups that we have, all of them have similar outbound rules. They allow access to anywhere on the internet, as you can see. Now, having said that, let us now look at the inbound rules for all three of them. The NAT guys, the NAT rules say all traffic allowed, provided the source is what? 0F5. And that means this one, the application security group. So that rule is something that we were playing with the last time. We modified it because we wanted our application security group entities, which are our application servers, to let them go out through the NAT. So we had that rule. But for right now, I would like to remove that rule because I want to make sure that you understand what is going on. So I will kill that rule right now, actually, like this. And save. And actually, one more thing, this NAT rule allows me to go in. But you know what? I don't want to go to the NAT device. So I will cancel that rule also. Oh, sorry, go back. So in the NAT situation, what I want to do is, remove this allow application servers. We'll create that rule later on. And me going to the NAT, I don't think I want to go to the NAT. Why would I? There has to be a need. So even I would not go. So I will remove this line as well. And basically preventing any inbound access to the NAT right now. Later on, we'll open up and allow machines in this security group to go to the NAT. We can do that fairly simply. Open the NAT access inbound rules and say edit and say allow traffic provided it is coming from the application servers. So you can say that, you know what? Yeah, go. Let the applications access internet via NAT. So we can keep that kind of a security rule in there, provided we have a NAT. But currently we don't have a NAT unit, a machine running the router software. All we have is just this security group that doesn't do anything for us. And once we have a router device, we need to, of course, go back to the route table in the private section and edit this route to include a route to the internet and then select NAT right here. But I don't have that NAT yet. So we'll get there. But right now, cannot do it. But just helping you understand what we're dealing with. So that's what we are dealing with, our security group selections, where we modified our NAT security group clearly and removed my access to the NAT because I don't want to go there directly. I would rather go there, but through the jump box, for which there is a permit rule already. I can go to the jump box. But the rule is for this jump box security group, and there is no jump box quite yet. We'll create it when we need to. The third one is inbound rules, and it says that, allow access provided it is coming from here. What is this? E88F. It is our jump box rule. So as long as the access is coming from the jump box, that's how, by the way, I will enter the VPC is through the jump box. So that is allowed. So go back there. I want to see application access, and that is allowed for port number 22 TCP SSH access only when it is coming from E88F. That E88F is jump box security group, and therefore allow SSH from jump box. Not for me directly. I, by the way, cannot even reach machines in the application security group collection. Only machines inside can, and I'm preventing any machines except unless it is the machine that is in the jump box security group called E88F. Only then access is allowed. That's how you should minimize access control from outside in perspective, also known as inbound rules. So we narrowed it down. However, there is something missing here, which is going to be needed, called database security group, that we don't have yet. So we'll create it in the CloudGenius VPC. And this is the group name called database security group, and I will create that. And in that, we have to specify some rules. So in the database security group, outbound rules are all open access anywhere you want to go, which is fine, but the inbound rules are empty. So just understand that it is empty. Now, from a design perspective, you would like your application servers to connect to your database servers. So what you would do is actually allow any access like this, provided it is coming from application servers, like that, and then save. However, what I just did was that I allowed access from my application B, my application A, these guys, machines inside that subnet, to connect to the database servers, like that. That's what I just allowed, as long as it is coming from 90F5, which is the application security group. I'm allowing all traffic. Now that is what we have. However, if you look for, let's say, the database server called MySQL, it uses a port number 3306. So what I should actually do is don't allow all traffic to come into my database segment, but only the port 3306 traffic, like here, as long as it is coming from application security group on the port 3306, only that should be allowed. So I'm further narrowing it down to that port, just that port, because that's what databases that I plan to use will be running on the port 3306, because I intend to use this MySQL database. If I intend to use another database, which is a beautiful open source database, the port number I think is 5432. So we can go back here and say that, you know what, in our applications, we are using not MySQL, but 5432 PostgreSQL. And as long as the applications are attempting to connect, maybe I can save both of them, or just get rid of one of them, or save both. It's really up to you as to what do you want to run in your database collection. Is it going to be just MySQL, or is it a combination of PostgreSQL and MySQL, or is it a combination of Oracle databases, which is not open source, or if it is, let's say, basically any database will have a custom port. You need to account for that port. So like this guy, PostgreSQL expects port number 5432 to be open for inbound access. So we are allowing inbound access provided the traffic is originating from 90F5, this guy, applications. As long as the traffic originates from here, 5432 PostgreSQL, okay. 3306 MySQL, okay. Other ports, other databases, okay. But adding all traffic, probably not a good idea. You can do that like this, but bad idea. So don't do that. I'm removing it. It's not crazy bad. It's just that I don't like it, because it is too much, or rather I should say, it is too wide open. Open too wide is not good. That's why all traffic, no. Only if you're running Postgres database and not running any MySQL, even delete that one and save. So now you exactly know what is allowed. Everything else is disallowed. And that's how you should think about these security group things. Another way to think about the security groups that I'm mentioning is the way you will classify your stuff. Like I am classifying my applications, and then all the applications that I will run will be in the application A, application B, application C, application D, like that particular series of subnets. So I'll put all of them in that security control group called applications. And then I can think of these things collectively in one fashion. That will help me sanitize my thought process in how I am structuring my application inbound rules and my inbound rules for databases and like that. So no matter which, whether it is A or B or C or any, no matter which subnet you're looking at, no matter which availability zone you're dealing with, the idea to think about security groups is to think of them as a collection of rules that will apply to a group of machines or services that you want to permit or disallow. So that's the idea underneath this concept of security groups that we are building towards. Now, once we have this kind of a setup ready, we now need to have NAT devices, at least 2 of them. So we'll begin with just one NAT for now. So let's go to EC2 and get a machine, and we can launch an instance and say that, you know what, don't launch this, because that's not a NAT. Of course, there is a one-line code I can give you to make that machine a NAT, but we'll do that later. You can just take any Linux box, any. I mean, just show it to you. Hold on. Let me see if I can find it. So actually, it's not one line. It is 2 lines. What are those 2 lines? Here are the lines. That is the line. It begins from here and here. Actually, technically, it is 1 line. That's the 1-line code you need to run. It is folded into 2 lines, but that's the piece of code you want to execute on any Linux box, any of these boxes, and that box becomes a router, just like these guys have here. Like the last time we were dealing with this, I guess. That's a NAT machine, Amazon AMI VPC NAT HVM. So we selected that one, and then we chose T2 Micro, and then go ahead and selected our CloudGMS VPC, and then we said that, you know what, you should go to public A or maybe public B, but that's the 2 choices for NAT. You need to put them in a public section, a public subnet. So if you're choosing your own Linux machine and you want to make a NAT box yourself, I'll paste this code for you. So we have it in an exercise already. So you will do that later. But just give you an understanding of what it takes to convert a box, any Linux box, into a router box is one or 2 lines. Then it just becomes a router. That's what masquerading. You by the way, you probably saw masquerade reference there. Masquerade, right there. That's what router does. Masquerades and pretends to be somebody else for things outside. So that's what masquerade function inside IP tables, which is a collection of, which is how Linux firewall works, is what we are modifying the Linux firewall on the box that we will deploy to make it a router. But right now we are just taking the lazy approach and take a ready-made router and putting that in our public A versus public B, whatever you choose. And let's go with A. And here I want to make sure that I get a public IP address, because that's what I want to do with the router, allow it to get to the world outside. So that public IP address is necessary. We get that. And then rest of the things we'll deal with later, not right now. There are lots of little things to understand. We'll do that. We'll deal with that later. For right now, just making sure that you get a public IP assigned, add some storage, and I still get this magnetic for some reason. That is stupid. I should remove that. I don't know how to remove it. I don't want to ever use magnetic standard storage. So I get general purpose. Tell me if you receive this magnetic thing as an option at all. I don't think you will see that. It's just that I see it because my Amazon account is like 10 years old or something like that. And so that's why I still have that option, this one. Okay, so we got a new disk allocated. We'll add some tags. Not tagging it, but go into the security group section to select carefully which one do I want And I know I'm creating a NAT, so I would like to put this in the NAT security group like that. And I know that all traffic will be allowed provided it is coming from applications. That's it. That's the only rule we have. NAT security group has the only rule. If traffic comes from applications, yeah, let them go. Do whatever they want. So review and launch. And I will now review and launch and select my key pair, which is this one, and acknowledge, and then launch. So you get a NAT machine. The NAT machine gets ready. But for NAT to function like NAT, there is a condition. If you remember that, it is to go and change our networking section to make the source destination check, make it disable. That's the only requirement you have from Amazon's perspective, is to make sure that the source destination check is false. If you don't do it, your poor NAT will not be able to function like NAT. So now that we have a NAT, we should go back to our dashboard in here, wherever we have our what's it called, VPC. So we go to the VPC section, and there we want to change our routing in the VPC. We want to go to our route table, to the private route here on the routing section, edit that, add another route, and let machines have access to anywhere on the internet, provided they are coming from this, not that, this. This is your NAT machine. I haven't labeled it yet. Otherwise, you can just select the name NAT and then get there. But right now, I'll just save, because I know that's a NAT machine. It is called 0E25A. Let's go cross-check. 0E25A should be there in EC2 as running instance called 0E25A. So that's the NAT machine. We'll now label it as our NAT A. What am I typing? Oh, my keyboard is misaligned. NAT A. That's my A NAT. You can have, for every availability zone, you can have a NAT and route them and have a failover setup. If someone dies, the other one picks up, like that. You can set up, and I'll give you examples of how to configure that. But more important than that is to understand what we are really doing, which is what we are really doing right now. So the NAT is in place, and now we can configure a slightly more involved picture of running a highly available load balancer to balance the load among multiple machines inside. So this load balancer concept is something that I want to talk to you a little bit about before I actually put it in place. So the idea of a load balancer is something like this. If you already know a load balancer, please tell me. So I can skip it. Excuse me. So if you have, let's say, you go to the Department of Motor Vehicles, DMV. In other states, some states like Washington will call it Department of Licensing, Registry of Motor Vehicles. So you know what I'm talking about. That's where you go. And you go there to do what? You go there, stand in a line. And there are lots of people like you waiting in line. And you go there and you get assigned a number. And then you wait. And there are these officers. That's it. There can be any number of them. You hope that there are lots of them, because the line is really long line. And so the idea here is that we have these officers that are hopefully available and serving you when you arrive. Like, this is you arriving. There are like so many people. And this officer is actually on lunch break. So now there are these two people available, two officers available. So let's go 1 and 2. There are 2 available right now. The rest of these people are on lunch break. Let's pretend. So this guy, his turn comes, and then he or she is said, you know what, you go here. Now this guy pops up. They get assigned to this door. or this gate or that window, and then they get serviced. These guys are waiting, and that gets boring. So what the DMV or RMV or DOL should do is to maybe expand the number of officers that they have quickly. And the moment they do that, this line will shrink rapidly because they will get serviced efficiently because there is this person that is assigning you a window number. So go to window number 1, or go to window number 2, go to window number 3, like that. That assignment is being done by this person. There is typically a person standing there, and that, think of it as a traffic cop. They're not really a cop, but they are a person. They're there to regulate traffic. This long line of people coming in. They're basically saying you go here and you go here and like that. So that allocation is what is a load balancer. That's what you're dealing with here in the context of cloud. So in the cloud context, what you're going through is this idea. When you have people visiting your website or your services, and there'll be a large number of them, they will all come and visit, and you run one machine here, poor guy. Everybody hitting that is doable, not that bad, it'll work. But at some point you have like 100,000 visitors, that machine might die, or maybe not die, but cry. And so it'll crawl, and the service that you are delivering to your customers will be slow, and they will complain, and that's not what you want. There's so many customers, sometimes millions of customers show up on certain very, very high profile or rather popular websites, I should say. And so you want to be able to service them and not make the machines crawl, not the people cry. So what do? You add more. What you do is you really actually add more machines, like here, M2, and here, M3, like that. But then you need somebody out here to regulate traffic. That's what a traffic cop does in physical terms, and a load balancer does in a cloud or rather machine context. So what a load balancer will do is that these guys, so many of them, will hit the load balancer endpoint. That's your traffic cop or load balancer. In Amazon's case, they have the word elastic added to it for no reason. I think they have a reason, but I just make fun of them. So elastic everything. So elastic load balancer, that's what they call it somewhere here. There's a load. Oh, they stopped using the word elastic, is it? Huh. They used to be called elastic load balancer. Now they just call it a load balancer. Not elastic anymore. Oh, there is still there is elastic load balancing. It's just not called elastic load balancer apparently. Whatever. So that's the idea. Now the concept is very, very simple here, is that you're basically creating a service here that will take the first customer and say, you sir, go there, and the second customer, you ma'am, go here, like that. It is basically keeping track of who goes where and allocating them to appropriate and handling the traffic. That's the idea behind a load balancer, which basically takes us to the idea that, this load balancer is a different function altogether. So we should go to our VPC and create a subnet just for the load balancer. Should we do that? Is the question I have. So we have a Cloud Genius VPC, and in there, should we have a separate subnet for load balancer or not? That's the question I'm asking. The answer is no, we don't need to, because this load balancer actually is going to belong on the public side. So the traffic cop or the load balancer sits right on these guys. Two of them at least for high availability. And so you can have the traffic cop sit on two different subnets like that. And then within application A and application B and any such subnets, you can have any number of machines that you can fit typically 250 each. And so you could fit any number of machines and they will be able to divide the work assigned to them by a load balancer that sits right here. So that's where load balancer will actually go on public subnets. Now the next question is about security groups. Do we need to have a separate security group called load balancer in our CloudGenius VPC? The answer is yes. Yes, we do. So we should create a load balancer security. So create a load balancer security group in the CloudGenius VPC because it helps us understand what is allowed, what is not allowed. Like that. So currently it is empty. All it does is allows the load balancer. That group allows outbound rules everywhere, no problem, but inbound, nothing allowed. So we want to expand this a little bit and think about what traffic should be allowed inside from the public. So we will expand it and say, you know what, you should allow traffic that comes from the public on HTTP protocol and comes from, let it come from anywhere on the internet. Unless you're blocking certain countries you don't want to, then you can scope it down. But typically you want to allow HTTP traffic from people outside. You also want to allow HTTPS traffic from people outside. And let anybody come in on the load balancer because that's how customers will come. And so you save it. That's your load balancer inbound routes. You're allowing people to visit http://https:// whatever services you're running, and they will land right on the load balancer. So that's what you want to allow. Now going inside, you want the traffic originating from the load balancer, allow that to go into the applications that you have in the applications security group. So in the applications security group, which is this one, you want to allow inbound access provided it is coming from the load balancer. So right now it allows access from Jumpbox, port number 22. You want to expand it and allow access to HTTP services provided it is coming from the load balancer. That was quick. So go slowly, load balancer. And then add another rule to allow HTTPS request provided it is coming from the load balancer. You want that traffic to come in to the application security group because it is coming from the load balancer. So you want to allow that and save. So now this rule and that rule allows traffic from HTTP and HTTPS provided it is coming from 41CEF. And that 41CEF is your load balancer. That's what you want to allow. Coming from the load balancer into the applications, let them in. And as you notice that I did not allow any traffic or all traffic, but only very specific traffic that I would like to be permitted. So only that portion is what I allowed. Now let's go back to our EC2 section and then actually create a load balancer. And that load balancer will fit on the public subnets, plural, double public subnets, not one, but more than one. And so we will go and see EC2 section. That's where it is hiding. It is called load balancers, and we will create a load balancer. Now here are the 2 or 3 different types. Which one should you choose? You have to read that. And let's understand what these 3 types. These 2 are new types. This one and this one is a new type. The previous generation is also available, which is that's what we have been using, but these are recently introduced new types. So I will read what these things are. and then decide which one is the right one for us. As you can tell that, we are talking about HTTP and HTTPS access for people outside coming into the load balancer. It is fairly obvious that we want this load balancer, application load balancer. So we'll create one. And we want it to be internet facing. So we'll say, this is my load balancer. It is facing the internet. And I would like that load balancer to listen for HTTP. I can add another listener to choose HTTPS if I want to. And then I will select the correct CloudGenius VPC. And in that VPC, I have 1A and 1B. And in there, I will need to select the correct public subnets, which are this one and this one. So I have now made sure that I am choosing 2 subnets for my load balancer, and they are public A, public B, like that, public A, public B. And that is important to carefully select, because this load balancer will sit on at least 2 or more subnets, and we want it to be the public subnets. So we'll create that load balancer right at the correct location. And having understood that aspect, we'll give it a name here, and then we'll configure some security settings. Now, since we have chosen HTTPS, it is asking us to provide a certificate. An HTTPS certificate looks like this. Let's go see that. So this opening up, a certificate looks like this. Oh, where is that? Yeah, there is a certificate that looks like that. So this certificate was issued to this site, and the certificate itself looks like that. It is issued on 13th of September, and it will expire on December 12th. And this is issued by an authority called the Let's Encrypt Authority. We'll have an exercise on this idea itself later on. And that is an SSL certificate. I would like to point out to you, and I have pointed out to your company people already in the past, but apparently nobody is listening, that your company's website doesn't have HTTPS, and it is dumb. There is no other way to describe it. It is stupid to have such a big company not using an HTTPS certificate in 2018. There's no other way to say this in very, very clear terms. It is dumb. Fix it, please. Fix it. Have your people look at what other companies do. So look at Apple, look at Microsoft, look at Google. They all have a certificate. It shows like a green colored item. That's what you should see, and you don't see it. That is bad. There is a reason why you should do it. Open Chrome browser and go to boeing.com, and you will see that the Chrome browser will tell you not secure. I think that's a good enough sign to let people in your company be aware of the fact that this idea is not considered secure by makers of the Google Chrome browser, which is the Google company. And that is something that you should bring to attention to your internal, I don't know who, you know it, I don't know. Just tell them, fix it. Remember to say this out loud internally to your company and say, hey, what's up? Fix it, man, fix it. That's what I want you to do internally. So having said that, we don't want to actually go in the detail of security certificates right now, which means I'll go back a step and remove the HTTP secure protocol for right now, because I don't want to complicate this unnecessarily. We'll deal with the security aspects later, or rather HTTPS aspects in another exercise, but not right now. So just not doing that right now. We will go further, configure security settings. And now it tells us that, you know what, improve your security. Your load balancer is not using a secure listener. So see, even Amazon is warning us, say, hey, you should do that. So you can go back and say, you know what, I'll listen to your warning and I'll just shut up and create an HTTPS certificate right on the fly, even though I'm not planning for it, but I'll do it. Let's see what happens. So configure security settings. Now it says, either you choose a certificate, which is a recommended step, or you upload a certificate, which can be done. So you have to go put a public key, private key certificate and chain. You have to provide that, which is the complicated part I want to avoid right now. We have to go and paste some things here in the private key certification body and certificate body and chain. I don't have that ready. So I will choose the easier route is to just choose from ACM. This ACM basically gives you a ready-made certificate. Amazon Certificate Manager, ACM, AWS Certificate Manager gives you a certificate. So we'll just use that certificate from something that I might already have, like that maybe. Yeah, that should do it. So I have done this in the past sometimes, apparently, and that's why I have this ready-made, ready to use a certificate. If you don't have this, you can always go and request a new certificate by clicking that button and follow the steps. So you give a domain name, it will generate a certificate for your domain. I have done these steps already. You can always put in your domain name like corycast.com and add another name like www.corycast.com. And these certificates are free from Amazon, by the way. And even Let's Encrypt is also free. And Let's Encrypt is not only free, it is automated free, meaning it is generate certificate for you on its own when it expires. So you don't even have to do a thing. You just set it and forget, and it's there for you and renewing it by itself without asking you for a credit card. And it is supported by open source companies. And I think it is the best solution for getting a certificate today, even better than this one. But we are on the Amazon cloud, so you can just go next and say, validate my DNS, set in a text record. And so in these domains, I want to go DNS validation. So there's a confirm and request. And then, of course, you can go and set validation records with these values in that name as a CNAME record and another CNAME record with this name and that value, and save it in your GoDaddy, come back and verify, and it's currently pending validation because I cannot modify your domain, but that's the idea. So that's how you go and request a certificate. I will actually go back and cancel this request because it doesn't make sense to me. I mean, it makes sense to you, but doesn't make sense to me because it's not my domain. Having said, I have it done already for my domain, so I'll just use that name and then I proceed forward. It says select a security group. We have already done quite a bit of discussion on security groups. So now is a good time to just pick the right one. They select us this default security group, which is a good one, but I would rather not use the default one. So what do? I use the one I created for it, like this one, for example, and not use that one. So since this is a load balancer, I have created a default, created a specific security group just for use with load balancers. That is called the LB security group. So that's what I intend to select, and I configure routes. Now in here, I have to create a target group. A target group basically has to have a name of some sorts. So my applications is the name I'm choosing. I'm using my HTTP protocol. By the way, what is going on under the hood? Let's go see that. Under the hood, what this load balancer is doing is, how do I talk to my machines inside? Well, you talk to them on HTTP on port number 80 with these machines on the applications security group across multiple different subnets, typically application A and application B in our example. So all of these, you will talk to them on HTTP port 80. The load balancer itself will also talk to these guys on 80. That's what we are describing here. HTTP port number 80, and the thing you will talk to is going to be a machine like that. That's in Amazon language, they call it an instance. In DigitalOcean language, they call it a droplet. In Google, they call it instance. But they're basically computers. So that's what I'm saying, instance. Select an instance. and target HTTP protocol and port number 80. And how do you check for health? You just go do an HTTP request and check for the path /. And that's how you will define your routing for a new target group. So this is going to be the target group for the load balancer to target. That's what we just configured. Then we register the targets. Now we need to have those machines, at least one or two, M1 and M2 running. We don't have them. Otherwise, they will just pop up right here in the list. Right now, we have only one machine running, but that's not what I want the load balancer to connect to, because it is the NAT. It is a router. I don't want the load balancer to go mess with router. Router is separate, and it has its own function and purpose in life. And so we will deal with that router separately. But load balancer should go to the application servers that are machines running in app A, app B, as a part of the overall application security group. We don't have them. So we need to create them now or later, doesn't matter. So we'll say we'll do it later, but not this right now. This is not the machine I want. So not that, don't select it, because I don't want you to target the NAT. Don't want load balancer to go connect to the NAT like that. That doesn't make sense. I would rather you go to a machine running some application. So we'll do that. For right now, I will leave it unchecked and go review. Now I have a review, I have a name, internet facing, protocol 80 and 443 from the outside. Inside, there is a security certificate stored for my domain. There is a security group assigned called load balancer. The routing target is, you will target to my apps on port number 80. There are instances running on HTTP protocol where you do a health check on the path /. And then there are no instances running. That means there is nothing here to do or go to. So the load balancer will immediately fail because there is nothing here on the instances side. So you will have a load balancer and it will immediately fail because it doesn't know what to do. It doesn't know where to go to. There are no machines here in M1, M2 like that. We don't have them yet. That's why the instances, target instances, are empty. So we create a failing load balancer and it's getting created. It's a successfully created load balancer and it doesn't work because it doesn't have any instances. So it has a listener which is listening for 80 and 443 on the outside on HTTP and HTTPS, but it is not actually connected to any machines by itself. That should pop up when you have actual machines connected and up and running. So you need to go and create two machines here. We'll select Ubuntu Linux and T2 Micro. If it is too fast, slow me down. T2 Micro, one machine, configure the details. I want to select in the CloudGenius VPC. I want to select this machine in the application A subnet. And I do not want to receive a public IP. Do not. Next, I will add some storage. 8 GB is good enough. Add some tags. Not right now. Configure security groups. And I have a ready-made security group already for that. It is called the application security group. So I will review and launch. And when I launch, I will select my key pair and I acknowledge and I launch. I do it one more time for the other machine, which is the M2 machine, just to illustrate you the concept of load balancing between two. And so here we go EC2, and then we select a new machine, an operating system, T2 Micro, configure the details, ignore that one, use the CloudGenius VPC, go to the application B subnet, and do not get a public IP address. Do not. Application B, do not get a public IP. And then we add some storage and then add some tags and add some security groups that we have chosen already for it. It's called the application security group. So we selected that one and then we say review and launch. And then we review, provide the key pair, and then launch. So now we have 3 machines running. Now we will go back to here and actually start another machine. Our jump box is missing. We have 3 machines running. One is a NAT, the other 2 are the application server called A. This one is called the application server B. So you have 2 machines A and B in the application A and B segments in our application security group on the appropriately chosen subnets that we already know and carefully selected. But we don't have an instance that will let me in. So I want to get that instance. I want to get a T2 Micro Linux machine, and I want to go to the CloudGenius VPC, go to the public A or B, doesn't matter, but one of these two. I'll say go A, and then here I want to get a public IP address because I want to go to the jump box. This is going to be my jump box. And so CloudGenius machine, public A is that I'm creating a jump box where I can go there. I add some storage, then I add some tags, add some security groups. And the security group I want to use is the jump box security group. And then I review and launch, and then I launch and I select my key pair and I acknowledge, and then I launch the machine. The machine will launch and it will create a new jump box for me, which I will use to connect to my machines internally. So on the EC2 section, you will see that I have a jump box coming up pretty soon. There are 3 instances. The 4th one is coming up. I will label it as jump box. Now that I have these 4 machines, they look like this from a picture perspective. So you have a NAT box. It seems to be in A. There is a jump box. It is also in A. Then I have 2 machines here. One is in A, one is in B. This is called the application server running A, application server in B. And I do not have a NAT here in B. Don't have a jump box. Having redundant jump box is like too much, so I don't want that. Have one jump box is good enough. So that's what we have. I don't have a redundant NAT yet, but now I want to go and I have a load balancer. I would like that load balancer to connect to this and this in A and B. So now I have the machines up and running. I'll go back to my load balancer and say, hello, go look at the machines, please. And so here we will say, you please look at my machines. So there is a target group we created, if you remember. It is called My Apps. That's the one we just created today. Apparently there is a different target group that I don't want anymore, so I should delete that. That's a confusing thing, so I just got rid of it. But this is the group that I created today. And in that group, you will see that I have no targets. But I want to add these 2 machines, app A and app B, as targets. So app A and app B added as targets. And then they are added. Now I want to save this. Now you will see immediately that as soon as the checks complete, that our health checks succeed, that our load balancer will show that it is correctly load balancing 2 machines. You will see that as soon as the response comes back as success. So in our configuration, you will see that the 2 targets that we have are not healthy yet. Healthy, say no. Availability zones, no. It is not healthy yet because they are not yet recognized as something that are added to the register targets. So it is going to be in an initial stage. The target registration is in progress. As soon as this registration finishes, you will see that these 2 instances, which are our app A and app B, they will become a part of the load balancer setup. And then, users can come in here on HTTP protocol and also HTTPS protocol, provided we configure our certificate correctly. There's one more step for that. It's a DNS step, which is what I need to be able to do later on. But I'll begin with HTTP, and you will see that users will successfully see what you show them here on the load balancer is what will get transported over as a request to these machines and these machines, and users will see whatever the applications are showing. So we don't have anything actually showing in the applications quite yet, but we will install applications right there and figure out what is going on from a user's standpoint. From a user's standpoint, they look at the load balancer at this endpoint. The endpoint name is this. So let's go copy that, and you will see that endpoint in the chat window. That's the chat, that's the endpoint we have. If you hit that link right now, nothing happens. It tells you bad gateway. That bad gateway basically means that you have a request that came in here, but it doesn't know what to do because it attempts to go here and it fails, and attempts to go here and it fails because there is nothing here running. That's what this bad gateway actually means. You need to have something, have some application running in the machine that you created here and here, but we don't have anything yet. So we'll put something on our machines, put some application on our running instances, A and B, app A and app B. These two machines need to run something. They currently don't run anything. And that's why you have your load balancer. There's something else going on here. It says request made to AWS configuration exceeds the maximum request rate permitted by your account. Fine, we'll deal with that. But right now, what you see in the target group is that these targets are not healthy. They are unhealthy because there is nothing running here and here. So let's go there and install some software that will respond on port number 80, saying, hey, I'm here, I'm alive. That's when this unhealthy becomes healthy and this bad gateway fixes itself. Right now, we don't have anything there. So we will go there to install something on those machines, for which we have to go through the jump box, for which I need to get this IP address into my configuration. So I'll go to my configuration and say, here's my config. And there I need to change this jump box address to that. That's what I have there. That jump box is taken care of. Next, what I want to do is go inside here in these sections, right? A and B. So what I want to do is look at the IP address patterns. We have 10.0.21.59, and here we have 10.0.20.65. If I look at this pattern here, 10.0, I can just expand it like this. So any address that matches that pattern will get picked up. So as long as it is in the pattern there, it will allow access to the machines inside. With that said, let's close the configuration and go back to our known host file and delete it. And then go back here and attempt to connect to our jump box. And so it says, yep, I know who you are, so please let me in, and I'm connected to the jump box, and our jump box is an Ubuntu box with an address of 10.0.10.11, as you can see here. And you can match that here. On the jump box, the internal address is 10.0.10.11. So we are connected to the correct box. But we have nothing to do with the jump box itself. What we want to actually do is to go inside on the application server A, which is this address. So I need to go to this address, please. So it says, okay, you are welcome. And we are in onto this internal IP address because we are entering through the jump box. As you can see, our known host file has 2 entries again. If you come back here and exit and say that I want to connect to the other machine right now, app B, and I get the IP address from there copied and go here and say, please let me in to the other box. So it says, are you sure? And I say yes. And it lets me in to the second box. And now we have 3 entries in our known host file, which is perfectly fine. Now that we have these 2 boxes we are able to connect to, what I want to be able to do is to go to both these boxes simultaneously on two different windows. One is the SSH for this, and the other one is for this. And why is it not responding? Yeah, it did. This one is responding, this one did not respond. So let's break it and do it again. Strange. Don't know why this is not responding, but we'll look at that. It should respond. We just saw it like connected 2 minutes ago, but apparently something is wrong. We'll find out that as to what is wrong in a minute. In the meanwhile, we have this box we are connected to 2159, which is our application. What is that called? B. The app B. So in that box, what I want to do is run some software, some web server software that will show something on the HTTP protocol. So the software I want to install there quickly is Nginx. So here we go. And it is able to correctly go through the NAT, go out, update, install Nginx, come back, and it is running. Now here you can see in that machine, we have here that one, this 2159 machine, we have our Nginx process running. Right there. Now, if you locally access the Nginx server, you will find that it is showing you, welcome to Nginx. Right there, title, welcome to Nginx. And H1 tag, welcome to Nginx. So it is showing you, that's goodness. So now if you go back to this machine, it is running something. This one is not yet. But what about here? On the load balancer, if you say refresh, we say welcome to Nginx because one of them is healthy. So if you go back to the load balancer and check on the target groups, even though one of them is unhealthy, actually both of them are showing unhealthy, but it is trying and updating the status. So soon you will see the status becoming healthy. And one of these guys, the app B specifically, this guy will show healthy in a matter of a few minutes because it is going to detect the updated status, which is functional. That's why you see it is functioning. So now we can modify this a little bit. And what I want to do is edit the page that shows up in there. And call it welcome to, instead of calling it welcome to Nginx, let's call it welcome to So I modified it. Apparently I need to go do sudo. So I'll go do sudo or quit this. If you're not familiar with this editor that I'm dealing with, don't use this. This is VI. If you're not used to VI, don't bother. Use Nano. If you're used to UVI, you know what I'm doing. So just look. Except that you should pay attention to what I'm doing. If you're not familiar with VI, that's no big deal. It's one of the most, I don't know, should I say good things or bad things about it, but maybe I'll crack a joke about it. So give me a second. Let me finish editing and I'll tell you the joke. So I think I edited that. Now this welcome to Nginx will say, welcome to app B. Hello. Why are you not showing me that? I just edited that, right? Huh? Oh, I edited in a wrong place apparently, because it is still not showing me the edits that I made here. Did I not save or what? I did save. Oh, I think it is picking up from some different location. So the joke on VI, VI is about 50 years old, roughly about 50. VI. Let's see what VI is. So VI was created in 1976. It's 42 years old. And people are still using VI. And the joke begins now. Because people don't know how to get out of VI. The joke now ends. If you have understood the joke, you may laugh. If you haven't understood, I will explain later on, not right now. But that was a joke. Now, the reason it's a joke is that it's so hard to come out of VI. If you don't know exactly how to come out of it, that's the joke was that people are still using VI for 42 years because they don't know how to get out of it. They're still using VI. That was the joke. It's a bad joke. Okay. Having said, let's see if the other machine is responding anymore or not yet. But let's go to app A, this one. And we'll grab the IP address right there and open in the other window, which we had somewhere here. That one, that window. That's what I want to go to. So we'll say SSH, please let me in. And it doesn't want to respond. Oh, it did, finally. Okay, so we'll install the same software there as well. And so here, by the way, before I install the software, let's go check our health status. So load balancer and our target groups that we have, one of them is showing healthy. Do you know which one? It is the B. App B is healthy now because we installed some software that shows you things like that. That's the good thing. Now we have this other machine that is still unhealthy because it doesn't have anything to show. So we will install that same software in here, or maybe a different software there. Let's go have fun with it. Little bit different web server. This is not how you actually do, by the way, in a real life production system. You will install the same software on a given application, but I am just having fun right now and deploying a different application, which is not what you should be doing, but I'm just doing it. Just telling you that this is not what you do, but just for fun, I'm doing it in a different application on the other machine. In reality, you want everybody to get a driver's license, well, irrespective of whether they go to this office or this officer or this officer. No matter which officer you go to, each of these people are interested in getting a driver's license. So these officers will give exactly what they wanted and not something else, like some other license. That's not the idea. So that's why our application servers, application A, application B, they all will run the same software, Nginx, for example. But I am going to B, this should be B. So I am going to run a different software, Nginx, and Apache software here, just to illustrate a point. That point I will first install and then show you the point. Let's go see. First of all, I'm installing this second machine called App A. I'm going to install Apache software. That is my plan. So here, not here, here. This is the App A. So install. What just happened? Okay, read that. Unable to fetch. What does unable to fetch mean? Unable to fetch. Something is not found. Yeah, the command is correct. It's not able to find something on this website location. Not found on that IP address. And what is that IP address again? Is it not ours, right? I don't think it is ours. Our IP address is on the NAT box is 18, and on the jump box it is 5255, and this address is something else. So what that address is, it belongs to the Ubuntu company. and that must be down or something. I don't know why, but there's a suggestion here to run apt-get update or try with fix something. So let's go try that. So when this update finishes, then we should try the first command again. And it is doing it this time. So there was a glitch somewhere in the Ubuntu servers that prevented the first time installation of this Apache software on the app A machine. As a consequence of what this installation will do is that you will have a weird setup, in which case that weirdness will be that for some of the users, this site will say, welcome to Nginx. And for some other users, the same site will say, welcome to Apache. That's what we did. So the idea here is to illustrate the point that we are dealing with different machines. App A and app B in a given load balancer is actually load balancing. So I will now change, or rather refresh this page and say refresh, and refresh again, and refresh again, and refresh again, and nothing changes. But I would like you to please click on the link that I have given to you in chat and see what do you see. So if you refresh, you should see something different. And I'll tell you why it is not changing on me, but why it might change on you. And I'll go into details as to what is the behavior and what it should be. But before I go there, let's go to the target groups and find out that one of them is still unhealthy. And the other one, the app B, is healthy, A is not. Now, if you go look at that link again, cut, and then look at a incognito window like this, which is called private browsing in Firefox. If you look at private browsing and try to go hit that same link again one more time, boom, I see Nginx. And I see Nginx again. That's what I noticed. I'll again go to Safari browser and see what this one shows. It says Nginx. I'll go to Chrome browser and see what this one shows. It says Nginx. But I would like to ask you, what do you see when you go? So please tell me. When you hit on that link,
see Nginx, and I'm using the Chrome browser.
Yeah,
So,
same.
okay. Maybe it is because that machine is not yet running, but we'll go check that machine directly once we hit that machine here. We'll see what it shows on a local access. So we'll say curl localhost and see what it shows us. Apparently, we are seeing Apache. So this is an Apache default page here. So Ubuntu's Apache default configuration. And this should, at the very top, should say something like, welcome to Apache, maybe, but you're looking at a page which is different from Nginx. That is apparently clear. So if there's modified from Debian original for Ubuntu, like that. So basically, this is the page that is different from Nginx. So it is there and running. Our load balancer hasn't caught the wind of the fact that it is actually running.
So I just refreshed and it shows the Ubuntu or Apache 2 Ubuntu default page.
I see. So now I see that both of them are healthy, and one of them is running Nginx, the other one is running Apache. So I will also now open up the browser and see what I see. What I see is what you see, is Apache 2. And I will refresh the browser again, and again, and again, and again. And now what happened? See, it came Nginx. I'll refresh again, I get Apache. I refresh again, I get Apache, and again, and again, and again, and again. And occasionally I'll see Nginx. Now I would like you to understand what is going on under the hood. So under the hood, what is going on? Let's go draw the picture. When a request comes in from a user saying, hey, give me something. So that's what we're talking about right now. In our current setup, we have a load balancer that is on two different subnets, public A, public B. And they this load balancer connects to two different machines called application A, application B. They are on private B, private A subnets. Now this machine runs Apache software. This machine runs Nginx software. And what you are noticing is that this load balancer is diverting the request coming from people like you and me over to here and here and here and here in a round robin fashion. That's what you're looking at, jumping from here to here and here to there. And that round robin is basically the underlying algorithm used to balance the load among two different boxes. And that was the reason why I set up two different software to illustrate the point that you can see that sometimes I see Ubuntu, sometimes I see Nginx. And that is amply clear. And I think you're also seeing the same thing. Having said, we don't want this kind of behavior necessarily in real life. So what do we want? In real life, we'd like to have the same exact server software here and here and here and anywhere else within the same set of application servers, identical, and not have this kind of a weird setup, which is, one runs this software. They're like totally obnoxious design. That's not how you should absolutely design. So having seen this idea, let us understand there are subtleties to this concept, and that's what I'm trying to head towards. The subtleties involve setting up the load balancer and carefully understanding what does it do for a user. So if you look at, let's see if I can show you that point. What is the stickiness? So the concept of stickiness is what I want to describe. So I will look for it first. Yeah, there it is. So the idea of stickiness is what I will talk about next. So the attributes called stickiness in the target group is what I will now describe. It is currently disabled. So when stickiness is disabled, what happens is when you open that link over and over again, it randomly goes to any of the machines available in the collection of healthy machines. Just assigns in a round robin fashion. You go here, you go there, you go there, like that. But when you insert stickiness like this and enable stickiness for a certain amount of time, for example, you can have the suggested value is 1 second all the way through 7 days. So I'll say, you know what, just say 1 day, 1 day, 2 days, whatever, doesn't matter. Just say days, fine, and save. So now my stickiness factor is set for 2 days. What does that mean? It means that this user, when he or she is accessing a service, every single time he or she refreshes the browser or goes to some other place and comes back to the same location, that user is always sent to the same officer, same application server, same exact machine, every single time, no matter what, for the next 2 days, until the cookie expires. What does that mean? There is a cookie here somewhere. That cookie is what is responsible for stickiness of behavior. And you want that stickiness, actually. So if you now look at our browser and say preferences and look at the privacy and history, and you can clear your history. It will clear all the cookies. That's a shortcut way of cleaning everything. I don't want that. Instead, what I want to do is to, or maybe I just clear the cookies, too easy for us to see. So I'll just close that window and close this window, close that one, and just clear out everything. Boom. So empty browser, clear data, all of it is gone. So it's a clean browser now. We don't have anything in our browser. So cleaned up. I'll even exit the browser. Then I'll start it again. Now you will see that when I hit that website one more time, before I hit, I want to go check my preferences and examine the cookies that I have. And currently, I don't have any cookies because I killed them all, right? You know that already. Having said, I'll open a new tab and go to that site one more time, like this. No, not like that. Why am I not looking at the keyboard? Okay, there. So it opens up Apache. It decided that I should go to application A. Fine. Look at the preferences. Here you will see that there is a cookie now. Where is the cookie? I need to refresh this browser page. It should show me the cookie. And the cookie, there is a cookie right there. So manage data, and there is a cookie, and it came from 22 seconds ago. It came from Amazon Elastic Cloud right there. And you can see that it comes from the same load balancer that we're talking about, LB, whatever that number is, East 1, and it came 22 seconds ago. If you read the cookie details, you will examine that it will live for 2 days, and then the cookie will expire. That's the policy we have set in our Amazon login for the load balancer for cookie stickiness period. So for the next 2 days, until I have this cookie active, this page will always go to application A, which means no matter how many times I refresh this browser page, keep refreshing. So 1, 2, 3, I will never see Nginx. I'm refreshing continuously one after the other. And I am not seeing Nginx no matter what, because it is stuck. Now let's go back here and clear the cookie that I have. So clearing it and say go bye-bye. Now I don't have a cookie. As you can see, the cookie is gone. Now go back here and refresh. And it is very likely that I will now see Nginx at some point. I'm refreshing. Actually, you know what? No, I will not, because there's a new cookie now. So there's a new, so hold on, refresh. So as soon as you visit the page, it sets a cookie and right there. So it is not going to show you. So I'll clear the cookie again and hope that I land on Nginx this time. And I did, good. Let's go back here and manage our data, and maybe refresh the browser and manage our data, and there is a cookie. And this is going to stick to application B running Nginx, no matter what I do, until the cookie dies or expires. So Nginx is going to stick with me, or rather I will stick with Nginx no matter what. And I'm refreshing the browser page over and over and over again. I hope you get the point. I think you get the point, because if you don't get the point, I am being stupid, not explaining to you properly. So tell me that you got the point. Or rather tell me I'm not stupid, one of those two. So let's go back to login. And I need to log in again because I cleared all my cookies. So the point of these cookies essentially is to give users a consistent experience. That's why we have cookies. So here I'm logging in and putting a second factor token. Hello. Yeah, there we go. And I sign in and I will reach my site. And by the way, somewhere in the backside in Amazon, I am reaching always the same set of web servers that deal with me. And therefore I have this load balancer visible to me, and all these things that I'm expecting to see are there. And in my target group, I have these 2 machines. Where is my target group? Target group, hello target group. And I have these 2 machines that are targets. They're both healthy and all good stuff. And no matter how many times I refresh, I'm going to see my own account. That's the idea underneath cookies. It is giving you a sense of stickiness, a consistency of experience. That's what is expected. That's what you're seeing right now. Now what you will see is the attributes that I set here for cookie set stickiness duration. You can set it to whatever your application requires. And this is just one of the several ways to set stickiness. I personally don't like this way of sticking, right? I personally don't like the way of setting this stickiness. You're welcome to do that, by the way. It's your choice. So I don't like it, so I will save it. Instead, what I actually prefer is to have your applications itself generate a cookie. Any of these machines that you will have, any number of them, they need to generate a cookie and they need to send the cookie over to the user's browser here. And that is a better approach to handling your cookies and expiration and login authentication and all the related aspects, as opposed to using this method, which is a valid method. It's just that I don't like this method. So that doesn't mean anything. If I don't like something, that has no meaning to it. You do whatever you like. That's what it means. So the other way of that I like, actually, I would rather have my applications create and maintain cookie states with the users. So a real life example of this from a user's perspective will be something like this. Imagine this situation called Facebook. So we have this thing that some of us use, some of us don't like it, whatever. So I seem to have an account with this company and I typically log in, and then I want to actually do an exercise right now with this as an example. So I'm putting a login token generator and sending a token, and then I will, upload a picture, for example. I'm just showing you what I'm doing. It's like here I'm taking a picture and no notifications, please. And yeah, just photograph. So I'm going to take some picture and say, hello, take this and show it to me on, where is that? Nilesh in Port Angeles. That's a good one. So we'll just upload that picture. So here me and my friends go to Port Angeles. And so I uploaded that picture over there and I might decide to share it. Now I actually don't want to share it, but I'm just driving home the point as to what I'm going to do and what applications you need to be thinking about when you are dealing with a setup like this, when your users are generating content. That's the idea. When there is a user generated content, like I just generated a new picture and I upload there, or I will upload there if I want to, is the idea that I'm talking about. So you have users here. Let's call this person number, or rather, this is me, and this is my neighbor. And both of us, go to a party and we have taken a bunch of pictures. So I go back home after the party and I said, here is the picture I took. And I say, hey, I am going to upload it to Facebook. So Facebook has a load balancer. Maybe let's not call it Facebook, but just any picture uploading site, generalized. So I upload that picture and I get assigned to this machine, application server number 32. And the picture goes from the load balancer all the way to the application and it gets saved right there. The picture P is saved. Awesome. Now the neighbor also goes there. And I tell the neighbor, hey, I uploaded the pictures. So go take a look. The neighbor logs in. Neighbor gets assigned to another machine, like machine 37, application server 37. That's the machine he gets assigned to. And he said, oh, where is the picture? I thought you uploaded a picture. So where is the picture? That's a problem, right? Similarly, this person, me, go there again tomorrow, or maybe 3 days from now. And then I want to see my picture. The 3 days later, I get assigned to machines called application 2. And I say, oh, where is my picture? So how do you solve this problem? So if you think about what I have discussed with you early on, is to never save anything right here or right here. or right here on these machines. They have hard disks, but don't save it here. Don't. So where do you save it? Where do you send this picture and actually save it on the backside in Facebook or in this picture or in this scenario? I'm not actually saving it, but I'm just describing the concept. So I'm closing it out and say, I'll leave the page. So the question I have for you is, this user, me, uploads a picture. I get connected to this machine, application number 32. And I just told you to not save the picture here because this picture P, there's a local hard disk. And you may feel like the application should save it right there. But you know what, it would come tomorrow, 3 days from now, and you say, where's the picture? I don't find it. The neighbor says, where's the picture? I don't find it. So what should you do? That's the question. What do you think? Where should you store it?
I feel like we talked about this. I just forget what it was called. Like a shared drive or something?
Yes, that's one possibility. But if it's a picture, you store it in a bucket.
Ah.
See, there's a bucket service available, right? Oh, no, not this. A bigger bucket service like that. So you just dump the picture in the bucket. That's it. So anybody will access that picture from here and just show it to the users. That's where the bucket comes into play. Now you see that?
So you're saying like Facebook uses buckets?
Oh yeah, everybody uses buckets. You also will use buckets. You already do. Yeah. So yeah, all of us. This is where you should use a bucket to store stuff that doesn't change too much. Of course, you can change. You can change the pictures, but pictures themselves do not change on themselves, right? Files do. So objects belong in a bucket. Files with data will belong on a database. Or data belongs in a database. Files will belong in a file system, like Elastic File System or Network File System or Samba or SMB File System or Azure Files or Google, a bunch of these solutions, wherever you want to store files. So imagine here me writing a letter and uploading it to the service. And so where should the letter go? The letter should not go to a bucket. Maybe it's not a letter. Let me describe it in a better, meaningful fashion. It's not a letter. Let's call it a Word document, like a living Word document that will be edited by multiple people. So not a letter, but a Word document. So doc. And I want to upload the doc to the service. So I get assigned randomly to any one of these machines. And I get, say, assigned to app 32 for again. So document, go, save. So my doc is now here. The doc should not be sitting there anymore. As soon as it arrives there, the application should take the doc and say, hey, I'm not storing you here. I'm putting you in a file system of some sort. There are various examples of implementation, like Elastic File System from Amazon, Network File System that you create yourself, or Amazon gives you, or Azure Files, which is a SMB, CIFS solution. So there is NetApp. There are commercial pieces of software available. You can create your own NFS solution, which is what I prefer. But again, that's my choice. So you can choose your choice and put your files, like a Word document, not here, but here, which is centrally controlled and managed and backed up. And so any of the other machines will also have access to it. So when this guy comes in, neighbor, he has permissions to review the doc. So he or she can then access it, the same doc, sitting right there, not here. That's what you deal with documents. And these are dummy examples of applications that I'm running here. Both of them are healthy, but they have the concept is what I'm really trying to drive at, not to create a confusion with with Apache running here and Nginx running here. It is confusing, by the way. I must admit. So don't do that. But that was just to illustrate a point. So with this understood, what I would like to now do is to walk you through the other ideas of expanding, or rather, maybe it's a time to reinforce these guys, security group, because that's one of the stumbling blocks that most people get stuck right here, and they get confused about what is allowed, why things work, why things don't work, and it is something to really carefully understand. So what I would like to do is to show you live examples of what things will behave like when we have our security group permission structure a little bit different than what I currently have. What I currently have is how it should be in the design that I had in mind. But by mistake or by oversight, if things are different than what we have, there are implications to these changes that I am about to make in the list of security groups that we have. For example, begin with the application security group. Now it has certain rules for inbound access. The machines in here allow certain things. What do they allow? HTTP, HTTPS, and also SSH. Since I'm done setting up my SSH, connection is not really necessary anymore. So I go from my jump box to these boxes, and I don't need to go there. So I can actually kill my jump box right now because I don't have a need to go there. I'm not in a rush to kill it, but I could. That's where this thing is going from. So TCP port number 22 allow from jump box. That's the description there. And that's what you're looking at. So if I don't have that rule, I will not be able to go in. If I don't have the HTTP rule, it will not flow in, right? This user traffic will not flow into the machines. So if I remove that rule, for example, like that, break, then my website breaks because it will give you a 502 error, which is basically, I don't know what to do with your traffic. I don't know where to go because nothing is responding, because that's what should be responding to the load balancer. This way, this way, this way. And you are breaking that rule by removing the HTTP connection. The rule was there like this: HTTP allowing from the load balancer security group. You will let HTTP traffic in. There is another rule here: HTTPS traffic you allow coming from load balancer. If you look at our load balancer again and look at our HTTPS traffic, which we have put in place, by the way, but I haven't actually created a certificate. Rather, I have not mapped this entry into a zone record for me. So I will need to do that. And I will do that right now by going to Cloudflare, which is where I store my domain. And I go to Cloudflare, I log in, and there I will go to my domain, look for DNS, look for AWS, which is the name I chose, and I find that there is this name, which is I need to change to this. No, not this. Copy paste. I need to get this copied, the link that I was using, and I'll put a CNAME alias to that instead and save. And so I saved it. That means now aws.cloudgenie.us is an alias of the load balancer. This load balancer. That's the alias. So this longish name that I had, that Amazon gave me here, it's so hard to say it. So I am going to not use it anymore. Instead, what I want to do, which I already did, is put a CNAME with a small friendly name like this and say, hey, what is your CNAME? So it says the answer section, aws.cloudgenie.us, is actually, boom, the load balancer. What just happened? We mapped a canonical name friendly, what's it called? Like Bob to Robert, alias Bob Robert. So this is the Bob, and this is your Robert. Robert is hard to spell. Bob is easy to spell. So I will now go to Bob and see what Bob shows. So here is my Bob. And what do I see? I see Apache, the same page we are expecting to see, like one of the two, either Nginx or Apache. One of those two I was expecting. You can also visit the same site right now and see what happens with the new name. Same site, new name, short name, Bob, also known as aws.cloudgenie.us. And tell me what happens.
I see Nginx.
Okay, so now the next idea. The next idea is like this. So we have set up HTTPS, right? And we have used a certificate that maps to this domain. So let's go see if the certificate works, which means I need to add an HTTPS right there. And I will. And I'll copy that link, go to a browser, open a new tab, and paste, and see what happens. So go. And we see Nginx. This is a private window, private browsing window. And what you see is there is a certificate in place right there. And it is verified by Amazon. For more information, you can see the certificate is valid. It begins in 2016 and expires in 2019, and it's issued to aws.cloudgenie.us and all that good stuff. So the load balancer that you're looking at is also functional under HTTP Secure, which means that we succeeded in correctly setting up this load balancer and making sure that it shows HTTPS traffic also. Now the next logical action that we should do is to put a forwarding of some sorts, meaning, which I haven't discussed yet, but what I want to do is when people visit line number 7, they should automatically be forwarded to line number 8. That forwarding we have to establish. And I haven't done that, and I haven't shown you how to do that yet, but that's the concept. If you visit this site, it will automatically forward you to the HTTPS site. Let's go test that. You will automatically see line number 11 when you go to line number 10. Let's go attempt. So I'm copying number 10 and expecting to number 11, expecting to land on number 11 in a private window like that. And it automatically should go to HTTPS, and it did. And you see the certificate there, here. And issued by Let's Encrypt. And you've seen this again before. Here's the certificate. You see that September 13th, when it was issued or began the validity, I was not even aware that they are renewing a certificate for me, because this renewal happens automatically. It happens every 3 months, and it just renews it for 3 months. Actually, every 2 months, renews it for 3 months. Every 2 months, it renews 60 days. And the renewal is for 90 days. And those, I just received notifications like that, hey, we renewed your certificate. That's it. And you can see those notifications coming, I think, in Facebook. That's where I think I received those notifications. So let's go see that. Notifications. First, Facebook there we go. So the new certificate was issued for something by somebody. There we go. There's a certificate issued by on the domain called Cloud Seminar, and it was issued by Let's Encrypt. And I just get notification like that. There's a feature in Facebook that does certificate monitoring, and that's what I'm using. And it is a nice feature to have. So that helps you understand HTTPS concept, which is what we were discussing here on the load balancer. Now going back to our security group discussion, we were focusing on these groups one at a time, and you will notice that we have both this as well as this verified correctly, and they all are actually working with a specific chosen DNS name, like I have in line number 8. Now the next item, database. This database thing is a separate collection of machines that will belong to a separate group of subnets called DBA, DBB, DBC, like that. And we don't have a database server running there. So what we can do is set one up. It is not difficult. You will see how easy it is. There are 2 ways to do it. Actually, there are more than 2, but I'll just talk about 2 different ways and show you both of them. Here is your EC2 dashboard. The most difficult way first. Most difficult way is do everything by hand way. So launch a new machine and launch a Linux machine like that, like here. Launch a T2 Micro. Put that machine in the CloudGenius VPC. Put that machine in our DBA. And don't get a public IP. Do not. With that understood, we'll add some storage. We'll get a general purpose SSD. But is it going to be a database machine? So we want to get slightly better performing SSD. This one. And if it's a really high-end database, you want to add more I/O per. Give me a second. You want to add more I/O per second numbers here. For example, maybe just increase this size to 100, and then you can increase this IOPS number to a larger number. Let's see if it allows you to do that. There are some limits to doing that. You can read how much IOPS you can get based on the size of the disk. So you can get a bigger disk and get a more IOPS provisioned. This is a better disk than this cheap disk. And so I'll get a better disk like that with a 5,000 IOPS. So it basically improves the disk performance. And you want to get a good, decent disk performance on the machines that are running a database. And of course, you don't want a T2 Micro like I have here in my example. I was selecting a T2 Micro machine, which is kind of a cheap machine. You don't want to be wasting your time and effort, and rather get a bigger machine like M4 large or like that. So you get a proper box for production usage. And I am using T2 Micro for now. And so you will go to DBA. You already have that DBA selected, IP address disabled. And then you will add some storage. In the storage, you will get highly provisioned IOPS. Provisioned IOPS is an input output per second. This is a better SSD than this one. So I'll select that one. Put a decent enough size on the machine, add some tags, and add some security group. The security group I want to select is already created for me. I created it myself for DB, and it is that one. And that allows PostgreSQL, which is not what I have in mind, but no big deal, we'll change it. I actually have MySQL in mind. So I will change this later on to port number 3306 to associate itself with the port requirement of MySQL database. Right now, the number is wrong, but it's okay. I can always change it. So that's the database security group. We'll now review and launch. And it says, you will not be able to connect to this instance as the AMI requires port number 22 to be open in order to have access. And your current security group doesn't have port 22 open. Okay. Okay. This thing doesn't know that I have a backdoor called Jumpbox. But of course, I will need to open port number 22 for it to come from the jump box, which is not open yet. So I will open that, but I don't need to go to the machine directly. That's what this is complaining about, is that, you know what, your machine needs to get port 22 open, and that is not open right now. So I'll say, fine, I'll deal with you later. And we will then launch. So when I launch, I need to select my key, and I acknowledge, and I launch. The machine is up and running, but it doesn't have any database quite yet, which is fine. We'll just go to our machines. This one is going to be our database machine. We'll call it DBA and save the name. We'll also go to the security group and examine the database security group access permissions for inbound access. And we need to allow, first of all, to change this to MySQL database. And as long as it is coming from the application servers, right? So this has to be the application servers. And save. I will also add one more rule so that I will allow SSH access from the jump box. And for testing, I will add myself access to the database from the jump box, because I just want to get that extra permission for testing. So I will allow SSH access, MySQL access, which is this one, from jump box. What I'm really doing is I want to test whether the database is functioning or not. We don't even have a database yet. We just have a machine. But I'm opening up ports for me to go from the jump box into the database server directly. This is what you don't want to do in a real life. You don't want to connect to MySQL from the jump box, but I'm doing it to show you. You want your applications to connect to the database on port number 3306, and that's it. You don't want this rule at all. From jump box to connect to the database is a bad idea. You don't want that. But I'm doing it because I want to show it to you as to what is, whether database is functional or not, whether we can connect to the database or not. That's what I want to show you, and I cannot show you if I cannot access. So that's why I opened this one up. You don't want to open it in real life. SSH access, yes, I do want to go from jump box because that's how I will set up the database server itself. Now, having understood these aspects, I will now go to my dashboard and look at these running instances. And I have my database machine. I want to get to that machine. So I'll grab its private IP, copied, and then go back to my machine here. And there I will attempt to connect to the database machine. This is 10.0.30.0, by the way. So I connect and it should let me in. And I am now connected to the machine dedicated to become my database server. This is going to be my database server. You can see that the machine has 96 GB of storage. This is the same 100 GB hard disk that I selected. If you remember, the high performing SSD, that's what you're looking at right there. 96 GB disk called XDVA1. That's the disk allocation we have. It is the correct machine. Now on that machine, I want to install a database software. Which one? MySQL. How do you do that? Like this. And it is installing. So we'll have a database server running. And it should finish in like 10 seconds, I hope, unless it is stuck. In which case, it is stuck because we don't have a route. So let's go open the route. That's how you find out that you have made a mistake. You go open the route. The route is that we want our database to be able to go out from the NAT. So we have to actually open the NAT rule. So go to the security groups, look at our NAT, and you will see that Our NAT doesn't allow inbound access unless it is coming from applications. So we will expand that and say allow traffic when it is coming from the database, please. I said database, please, and save. As soon as I save this, my traffic should start, which means this one will work the next time I attempt. So here we go. And it is working. He's going to install that database software called MySQL in 10 seconds. Once the software gets installed, I will use it. So software installed. What I want to now do is see if database is running. And it is running. Now what I want to do is to see if I can actually access the database, for which I need to install a piece of client software called MySQL Client. So I might have it already. I think, let's see if we have MySQL Client. Okay, yeah, the thing is functional. You can see that access is denied because I didn't even type a password, because I don't even have any password, because I didn't set it up. So the default password is what is set up, and we want to actually configure the server deployment in a fashion which correctly sets up database and a user and a password. Without that, I cannot access it. But what I want to communicate with this idea is that there is a database server correctly functional and access is denied because I don't have access to it. That's the core idea here, is that we haven't actually have created a user and a password for accessing the database server running on this box right here, to which I close the connection. So from a picture perspective, if you now look at what we have, it will look something like this. So up until now, we have users connecting to HTTP, HTTPS on a load balancer that has multiple connections to, too long, multiple connections to two machines called application A, application B. Those two machines that we have. We also have another, this is, by the way, a subnet. This is also a subnet. This is the public subnet. This is a private application subnet. There's another subnet here called database, in which we have only one machine, DBA. In the public subnet, we have a NAT box. We have a jump box. This is me. And I connected from jump box to here to set up Apache. I connect from jump box to here to set up Nginx. I connect from jump box to here to set up MySQL. And then I have this load balancer. This load balancer is connected with these guys. And I have open permissions for this application to connect to the database. I have open permissions for this application to connect to the database here, as well as any others that I might have. If I create another one, I could. And we will have such a configuration created according to what we need to have. So this is where you look at where I have set up a database server called MySQL. There is no such machine here yet. And in this setup, I did not include a username and password and a database name. So we have no connection at all, and connection fails that you saw. That's one basically nuts and bolts way of setting up whatever you want. So in my example, we set up a database server ourselves. This is the most difficult way of doing things. An easier way is to not do this. but instead use a ready-made service. That ready-made service involves paying money. Not for the first year, by the way. First year is still free. And the first year, what you can do is to, first of all, go back to the dashboard and look at the running instances in the database machine and say, you go die. So we kill the database instance because we don't need it anymore, because I'm going to do this a different way. The different way will involve using a ready-made service. That service that we want to use is called database service, simply. So the database machine that I have is dead or almost dead. I will now go back to my database solution sets here, database, and there I will start a new service called RDS, for example. This is one such service for databases. So I'll just use that, RDS. It will give me multiple choices of which database servers do I want to have. So here, Amazon RDS is a service to create database services that you will use, and you can get a choice of a variety of databases. So let's go click one and create one. Here we get a choice of 6. This is one choice that I like. And whenever I say like, it is purely my preference. Don't take it good or bad. It's just my choice. This is what I like. And this is actually my preferred, really, really good choice. This one. Both of these guys are open source. And even this is open source. This is also I like. MariaDB. So that one and this one are basically the same exact function. They're identical in operation, these two. Exactly identical. There is no fundamental change, except it's a different software that behaves exactly the same way. 2 different open source projects, MariaDB and MySQL. The reason why people created this one is because this Oracle acquired, and apparently some people don't like Oracle. So they said, you know what, we don't like you anymore, we'll create our own. So that's where MariaDB came along. Is basically functions identically, binary compatible, identical to this. Works exactly the same. But people prefer this for philosophical reasons, or I don't know what reasons. Some claim that it performs better than MySQL, but I don't know, I haven't measured. This one actually is a very good and very old, it's like 40 years old, I think, roughly, maybe less, but a very stable, established database solution that works. And it is fairly comprehensive, and I think is the best open source database solution available is this. And it is free. Free as in open source. Free as in freedom. Not $0. This is going to cost you money because you're going to run a service. So the service is not free, the software is free. First year is free. This is the Amazon's implementation of this guy. So they're basically the same as MySQL. Aurora is claimed to be a better version of MySQL, but again, our Aurora is a claim from, in fact, there's a claim right there, up to 5 times the throughput of MySQL and 3 times the throughput of PostgreSQL. That's a claim. Fine. So if you like that claim, you go that route. I don't like that claim, so I don't go that route. I go here or something like that. Now, this is a commercial software. You have to pay extra money just to get the software and then run it. This is also another commercial software from Microsoft, and this is from Oracle. So there are various database choices. You select whatever you want. And in my example, I will choose this, or maybe this. That's what I'm going to select. And I begin forward. What I will do now is go next. And here it's telling me that you can choose this option, which is recommended choice from Amazon, because that's what they want to push. But I want to choose this because that is my choice. So it's MariaDB production deployment in multiple availability zones. So I will have one here, like that. Or if you're just testing, like we just did in the first step, then we don't have to have DBA and DBB. We can just test with one. That's the test deployment right there. Testing or development. Just have one. If you want to have multiple availability zones, you go that route, production deployment, and go next. Now you get to choose what login names and permissions and passwords and everything else that you want to have. The license that we have for this software, MariaDB Community Edition, is General Public License, GPL. You can choose the engine version. Lots of versions available. I'll just go with the latest. Now the size of the database machine itself. You can get really, really small all the way to really, really large. So here we go to the smallest one, DBT2 micro. That gives you a machine. Now here you can create this database service in multiple availability zones. That's going to be a multi-availability zone deployment. So you create a replica in different zones. That's what we have in mind. So DBA and DBB, that's what will become multiple availability zones as we go along. Or you can say no to it, in which case it will not do it. But if I say yes, then it will. Now storage type, you can of course provision to a better quality SSD and allocate some storage and allocate some IOPS, so maybe higher number, like this, for example. And then it'll tell you the monthly cost is going to be that number. You will notice that the machines themselves cost you $24. The storage will cost you $25. The provisioned IOPS will cost you extra money. So maybe I want to reduce that to 1,000. If I reduce that to 1,000, the cost drops. So the higher speed, higher performance higher performance disk costs you money. You reduce that number, the price will go down, actually a little bit, not too much. But if you reduce this number, the price will go down even further, like that. So the recommended size is 100, so they suggest that you stick to 100. And the provision IOPS will be, I think, say about 1,000 is good. And that's the monthly cost you will go with. Now here you will give it a name, the database identifier. So you have to give it a name of the database, name of DB, and give it a username, like Nilesh, for example, and a master password. You can call it whatever you like. You can set a password. Password do not match because apparently I was making a mistake in typing. Okay, the password match. And you go next. Now, what you need to do is select the VPC that you want. So I want to select the CloudGenius VPC. And there I have created a subnet already, but it is prompting me to create a new availability DB subnet group. Now I would like to choose my existing subnets, but apparently I don't see that option for some reason. I would rather have my own subnets created, or rather used, as opposed to creating a new subnet group. Apparently that's what it's forcing me to do. I would rather not, but don't seem to have a choice there. It should say that, hey, you already have subnets called DBA, DBB, so just use them. It is not letting me do that. So which means it's going to create new subnets for us, which is fine. I don't want these machines, database machines, to be accessed publicly. So I'll say no. Do I have a preference on availability zones? I say I do, 1A and 1B. That's what I would like to have. But it's not letting me multi-select. Let's go see the info as to what they have. Choose the DB subnet group that defines which subnets and IP address ranges can it have in your VPC. So it should let me select my own, but it's not doing it. Let's just go with what they are suggesting. So we are going to choose an existing security group that we have. The group that we have is called DB. So I chose that DB security group, which showed up here. And the default is not what I want to use. So I chose the DB security group, and US East 1A, and a new subnet group will be created. And as we go along, we have to have a database name. So name of the DB. What was the earlier name? Earlier name was the name of the machine, I think. This is the name of the DB. I think I chose that name also, name of the DB. Then there's a port number specified. There's a DB parameter group and option group that are specific to MariaDB. You can set encryption if you like, but our cheap machines that we have, T2 Micro, do not support The engine do not support storage encryption, so we are not getting that choice. That is a possibility. You can go that route and take it. There is an automatic backup option available here. So every 7 days, the backup will rotate. So you'll have a Monday backup, Tuesday backup, like that, and then on Sunday it will backup for Sunday. But then come Monday, it will again overwrite. So it's a 7-day rolling period. That's how you can structure it like that if you like. You can set time windows to when the backup should be taken. If you don't have a preference, that's fine. And it will take backup of the database and put that in a bucket for you. So that's the idea behind it. It's an automated service. It will automatically take backups, put that in a bucket for you, so you can readily access the database backups if you like to. You can also enable monitoring for performance of the database machines themselves if you like. You can also capture logs and put that in a log monitoring service. So CloudWatch is a service. You can export these logs directly and they'll get exposed to the CloudWatch service. That is a choice available, that you may want to grab those logs and store that in an external service. You can also enable automatic updates to the database software itself to minor versions. You can upgrade them by itself in a specific time window if you like, or you don't want a time window, that's also okay. You can also enable delete protection. So if you accidentally go back to the Amazon console and delete the machine, it will prevent you from deleting. That's the protection idea. Now here, if you click the create button, it will actually create a bunch of different resources as you're looking at. What I want to actually describe to you is the idea that is going to happen is it will not use the existing database or existing DB subnet collection that we have, DBA and DBB, but it will create another subnet, or rather a group of subnets, 2 or 3 depending on what it does. And then in there it will have instances created called DB-T2 micro running your MariaDB here and here and here, and any number that you select. And it will manage this as a service that you need to use. So you will actually get rid of this subnet that you have manually created and just go with what Amazon is creating as a ready solution for you. And then you have your applications connect to the database service like that, depending on how many nodes that you actually provision and allocate. And that's the underlying concept of reusing a ready-made service. As you will notice, if you configure it through RDS, it gives you a lot of different features to do backups, to incrementally update, to do snapshots on a periodic rotating basis, dump it in a bucket. And so from a structural perspective, it will look something like this. And I think I have my own method of taking snapshots. So you will see that in S3, where I have a place to dump the snapshots, they go back here. And these are the snapshots of our CloudGenius websites that you can see that are apparently last modified. If you sort by last modified, the oldest snapshot I have is in January and March and like that, but all the way through the last 7 days. That's what these are older ones below that. But here is September 28th, and every day 28, 29, 29, 30, 30, 1, 1, 2, 2, like that. It will automatically take a snapshot and dump it in this bucket. And the snapshot is actually happening in Google Cloud. So what you will see is that actual services are running here in the Google Cloud. And from here, I will dump into, hold on, I think I typed the password incorrectly. And from my Google Cloud, I am dumping my backup snapshots of the entire setup in Amazon's buckets. It's crazy, but that's how I do it. You don't have to use Amazon's bucket. You can use Google's buckets, but I chose to put my backups on a rotating basis from Google Cloud, push it to Amazon Cloud. That's how I have set up. There is no logic to it. That's just how I did it. So that's what I have. That's what you're looking at from a backups perspective. And so these backups will automatically update. So like sometime during the day, right now it's what, 5th of October. So the 5th October backup will happen and it will pop up right here. And tomorrow you will see that the September 29 backup, sorry, let me check sort by date modified. September 28 backup will disappear. And a new backup here on top, October 5, will show up. And that's the rotating backup that I was describing to you in the Amazon's service example. Like Amazon's database service, every cloud will give you such deployment of database services. For example, here is SQL deployment. So that's your create an instance scenario. You can create a MySQL or a PostgreSQL, and you can choose to go MySQL. And here you can deploy a MySQL development or staging area or a production. A production will actually deploy multiple high availability setup. It will use a large machine with 15 GB memory, 25 GB SSD with 4 CPUs. And if you configure that, that's what you will notice is that it will have a choice of whatever root password you select, and you choose the region. Central is my preferred location. I think I know my preferred location is different. I think my US West 2, that's my preferred location. And I can choose any zone, 2A, 2B, 2C, depending on what the choice is. I just let it select by itself. And then I have database version choice, set public IP connectivity choice. I would rather keep it private and not, hold on. Oh, it's not private connectivity. No, I don't want it. Don't want it. So what I would like to actually do is to add specific authorized networks. So only the machines inside can access. This is another way of configuring tight security. And you can specify that only machines inside the Google Cloud will be allowed to access this database service. You can choose the machine type, disk type, automatic backups, date and time window, database flags if you have any, maintenance schedule if you want for updates, and then create a service. And that's what will construct a automatic database service in your cloud for you from these cloud companies. There are other cloud companies that will go to your cloud and create a database service in your Amazon account. That's also possible. If you see that there is this company, what's it called? I think IBM acquired it, IBM database service. IBM has acquired it. It used to be called, what is it called? Maybe here. Compose. Yeah, Compose Cloud. I think it was Compose. So if you try Compose, what it will do is ask you to set up MySQL in the Amazon cloud. With a chat request. Okay, I understand. So I must have timed out. Okay, yes, I did. So we'll continue this discussion. I want to stop recording right now. We are already beyond 7. So I'm stopping to record. I am going to let you enjoy your weekend. It is Friday today. So enjoy your weekend and we'll get together again on Monday. In the meanwhile, if you have a question or something, always come and ping me on in any method that you have. How come this camera started today?
Okay, thanks, Nilesh.
Thank you, guys.
You.
Bye-bye.
Have a good weekend.
Bye-bye.